Let's talk about sketching and interpreting diagrams. We're about to start one of the most important parts of this class, which is writing proofs. It's basically like we're going to take all the things that we've learned so far and scramble them all together and see what we can come up with. One of the most important skills that you have to have in order to be successful with writing proofs is knowing how to look at a picture and know what it tells you. Because in geometry, there's some things that you get to just assume are true based on looking at a picture, and there's other things that you're not allowed to assume are true unless you're told that they're true, either with words or with special markings on the diagram. So the first thing we're going to talk about today is what can you assume by looking at a diagram. One of the things you're allowed to assume is that two lines intersect at a point. So without me telling you anything else about this picture right here, just based on the lines and the points and the letters on those points, you can assume that B is the point of intersection. And similarly, you can assume that planes intersect at a line. So just by looking at this picture of plane P and plane Q, you can assume, based on what you see, that line M is where they intersect. You can also assume that lines or planes exist if you have enough points to define them. In order to define a specific line, you have to have 2 points. So in other words, if you had a diagram that looked like this, you had point G and point H, you have enough information to say that line GH exists. Similarly, if you have 3 points, you can make a plane. So if you have 3 non-collinear points, I, J, and K, that's enough information to assume that a plane encloses those points. You can also assume that points are collinear. Looking at this diagram, since it looks like X, Y, and Z all lie on that same line, you're allowed to assume that they all lie on that same line. And even more than that, you're allowed to assume that those points go in the order that you see. You know that Y is between point X and point Z based on what you see in the diagram. And that's important because you can also use that information to assume the segment addition postulate. Since points X, Y, and Z are collinear, and Y is between points X and Z, you can assume that XY plus YZ equals XZ. It's important to note when you're using the segment addition postulate on a diagram that involves a line, you're really only focusing on the segment part of that line. So this arrow out here and this arrow out here really don't matter for the segment addition postulate part of this problem. You're only focusing on the segment that's in between X and Z. You can assume that angles are adjacent by looking at a diagram. Remember that adjacent doesn't tell you anything about their measures. Adjacent just tells you that 2 angles are next to each other. So based on what I see in this diagram, angle LMP and angle NMP are adjacent because they both have vertex M and they share side MP. And that's important for the same reason that being able to assume points are collinear is important. It allows us to use an addition postulate, in this case the angle addition postulate. If you have 2 adjacent angles, like the ones we were just identifying on the previous slide, then you can assume that one of those angles plus the other angle equals the entire angle. That's the angle addition postulate. And you're allowed to assume that if you have 2 adjacent angles. You're also allowed to assume that something is a linear pair. Really, a linear pair is just a special kind of pair of adjacent angles. Like angle QRT and SRT, they're adjacent angles. But because their non-common sides are opposite rays, or another way to say that is that Q and R and S are collinear, that's one of the things we get to assume, that means that these have to be a linear pair. And you can assume vertical angles. Remember, the definition of vertical angles is that they are non-adjacent angles formed from the intersection of 2 lines. Well, one of the first things we said is that you can assume that 2 lines intersect, so I can assume that. And if you can assume adjacent, then you must be able to assume non-adjacent as well. So something like angle ABD and angle EBC, those are non-adjacent angles because they only share vertex B and no sides, and they were created by the intersection of 2 lines. Therefore, I can assume that those angles are vertical angles. So that was a lot of stuff that we are allowed to assume just by looking at a picture. So what am I not allowed to assume? All of these things, and more things that we haven't even learned about yet. But for now, these are a few things that you cannot assume unless it's marked on the diagram, or if it's written in words. You cannot assume that angles are complementary, and you cannot assume that angles are supplementary, unless you're told their angle measurements are 45 and 45, or 140 and 40, then you could assume it because you were given information that would lead you to that conclusion. But if you just have a picture that looks like you have two complementary angles, that's not enough information for you to actually say for sure that they are. Now you might be saying, well, wait a second, on the supplementary thing, I thought you just said that you could assume that things are a linear pair. And that's true. You are allowed to assume that something is a linear pair. But you're going to need something that we haven't actually learned yet. We're going to learn it in the next lesson. It's called the linear pair postulate to say that they're supplementary. The definition of linear pairs does not actually say that they're supplementary. The definition simply says that they are adjacent angles whose non-common sides are opposite rays. And I taught you that they're supplementary because they are. In our next lesson, we're going to learn that the reason that they're supplementary is because of the linear pair postulate. And you're going to find this quite frequently in geometry, that you're going to have to pair different things together to get to the conclusion you're trying to get to. Which is why we've been talking so much about the law of syllogism, which is linking different statements together to get to a final conclusion. So an example of that right now would be that if you have two angles that are adjacent and whose non-common sides are opposite rays, then they're linear pairs. So that's my first statement. And then my second statement would be, if I have linear pairs, then they're supplementary. So since those were two different statements in a proof, which is where we're going with this, that would be two different steps in your proof. And therefore you would need two different reasons in your proof. One would be the definition of linear pair. The other one would be the linear pair postulate. Now, if that didn't make a ton of sense, that's fine. That's just a quick preview of what we're going to get with proofs. That's going to take us like a whole week to get through proofs. So if you're not totally clear on that yet, that's fine. We'll get more practice next week. So here's some other things that you can't assume are true. You can't assume that an angle is right. Just because it looks like it measures 90 degrees doesn't mean that it is unless it's labeled. You can't assume that angles or segments are congruent unless it's told to you either in words or with markings on the diagram. And you can't assume that a point is a midpoint, or a line, ray, etc. is a segment bisector, or that a ray is an angle bisector unless you're told some kind of information, like that you have congruent segments or something like that. So let's talk about what some of those labels look like. You're actually pretty familiar with them already. I've mentioned them at least once or twice earlier in the year, but now we're formally learning it. If an angle is right, then you can label it as being right with a little square at the vertex. So on this diagram, we would be able to assume that angle ABC is a right angle because it's marked. If there was no little square at the vertex, then we would not be able to assume that angle ABC was right. Even though it looks like it's right, it doesn't matter what it looks like, because your brain and your eyes can't tell the difference between an 89-degree angle and a 91-degree angle or a 90-degree angle. So just because something looks like it's a right angle doesn't necessarily mean that it is, unless you have this little marking. Segments can be labeled as congruent with matching marks. So segment AB and segment BC, these two segments have to be the same length because they have the same mark. And remember this little symbol right here, the equal sign with a squiggle on top, that's how we say congruence as a symbol. So this would be read, segment AB is congruent to segment BC. Now you'll notice that these markings on CD and DE are not quite the same as the markings on AB and BC. These ones have two marks instead of just one. That tells you that segment CD is congruent to segment DE, but it's not congruent to AB or BC. If you had more congruent segments than just these two groups, you would just keep adding marks until you have 3 marks, 4 marks, however many different sets of congruent segments you have. Labeling angles as congruent is pretty similar, except instead of a straight line, you're going to use an arc. So based on what I see in this diagram, angle ABD and angle FBC must be congruent to each other, because they both have a single arc. Whereas angle DBE and angle EBF, those ones are congruent to each other because they have matching double arcs. But since theirs are double arcs, that doesn't match angle ABD and FBC, so these angles are congruent, but they're not congruent to these two. And these two angles are congruent, but they're not congruent to these two. And same with segments. If you have more than two sets of congruent angles, you just keep adding extra arcs to make as many extra groups of congruence as you need. So let's get some practice with labeling a diagram. The first thing I want you to label is angle BAG as being a right angle. Well, a right angle has a little square at the vertex, so I would just draw a little square right here. Next, I want us to label that angle BAC and angle DAC are congruent. Well, that's these two angles right here. And to label angles as congruent, I use arcs. So I'll label BAC with an arc and DAC with a matching arc. Now, it's important to note what's going on here where the arcs meet. Notice how they're, like, it's not one big smooth arc over the whole thing. These arcs are independent of each other. Right? This one was its own arc, and this is its own arc that you add on extra. You don't make a big fat arc over the whole thing. Each angle gets its own arc. Now let's label GA and AD as being congruent. GA is this segment, and AD is this segment, so I'll mark them with matching single marks. Whereas when I mark these next ones, since this is a different group of congruents than the first group that I had, I'm going to label these, which is, let's see, this segment is BA, and this segment is FA, and this segment is EA. I marked all three of these with double marks to indicate that they're all congruent to each other, but that they're not congruent to GA and DA. And let's label angle GAF and angle FAE and angle DAE as being congruent to each other as well. So since I already used a single arc to label these angles, I'm going to use double arcs to label each of these angles. And again, you'll notice that it's not just one big giant double arc. Each angle gets its own double arc. Okay, well that's how we label a diagram that's already been given to us. Sometimes you're not given a diagram at all. You have to draw the picture for yourself based on the words that you're given. So let's take a look. Angle ABC and angle CBD form a linear pair, and we're supposed to just draw that. Well, the first thing you might want to do is label the letters all over the place, but do that last. It can be confusing to figure out where your letters go when you don't even have something to put letters on. So instead, start with the kind of shape that you're supposed to be creating. We're supposed to make a linear pair. Well, a linear pair, that's a pair of angles built from a straight line. So I can draw a straight line, and then I can draw a ray coming off of it, and bam, I created a linear pair. Now I just have to put points on here and label those points with the corresponding letters to make each of these angles. Well, I noticed that both of these angles have B, and that B is the vertex of both of those angles, because B is in the middle of the two letters. Well, the vertex of both of these angles is this point right here. That point has to be B. I also noticed that both of these angles have C. Well, out of the 3 points that I have left to label, which one do both angles have? That would be this point, point C. Since both angles have that point, I'm going to call this one C. And then I just have A and D. It actually doesn't matter which one you call A and which one you call D here. I'm going to call this one A. Let's double check, angle ABC. Yep, that's one of my angles. And I'll call this one D. Double check, angle CBD. Yep, that's one of the angles. So here I have a linear pair with the appropriate names that I was given. I have sketched this diagram correctly. Let's try another one. Angle EFG and angle HFI are vertical angles. Again, it can feel overwhelming at first when you have all these letters. It feels like you're reading something in Greek. Don't worry about the letters yet. worry about the shape first. We're being told that these two angles are vertical, so I need to draw vertical angles. Vertical angles are non-adjacent angles created by the intersection of two lines. Well, that means I need to draw two lines that intersect. And then I can pick either pair of vertical angles. Remember that every pair of intersecting lines creates two pairs of vertical angles, so it's really up to you which ones you want to call EFG and HFI. I'm going to pick these ones on kind of the left and right, the acute angles of the bunch. So I need to label each of my points with the corresponding letters. Well, I noticed that these angles both have F. F is in the center of the angle's name. That makes it the vertex for both of these. And this is the vertex for both of those angles, so that must be point F. And from here, it's actually kind of free-form. Whatever you want to call it works as long as you keep E and G on one of the angles, and H and I on the other angle. Notice that none of the other points match between these two angles, only F was in common between their names. So if I want to call this angle over here EFG, then I can put an E on this point and a G on this point, and I've created angle EFG. And then I can take H and I and put them here and here, and I've created angle HFI. So quick double check, did I draw what I was supposed to? Do I have vertical angles? Yes. Are they called angle EFG and HFI? Yep, that looks good to me. Let's try another one. Q is between P and R, and segment PQ is congruent to segment QR. Well, this first half is actually pretty familiar to something that we did at the very beginning of the school year, which was the segment addition postulate. We got this kind of information quite often, and I told you to just draw the point that is between the other two, and draw points on either side of it, and connect it with a line. So I have Q is between P and R. But now I have this extra information that I need to label as well. I need to show that PQ is congruent to QR. Well, that's both of the little segments that I created, right? PQ is on the left, QR is on the right, and if they're congruent, then they just have matching marks. So voila, I've created my diagram. All right, let's try a hard one, because this one has 3 different pieces of information. Let's take a look. Angle XYZ is a right angle. Ray YW is a ray in the interior of angle XYZ, and angle XYW is congruent to angle WYZ. Holy crap, that's a lot of information. Let's just take it one step at a time. The first thing it says is that I have a right angle, so I'm going to draw a right angle. Now, just because that looks like it's right, doesn't mean it actually is until I add what? Yep, a little square. Now I've created a right angle. And I have to name it. Its name has to be XYZ. Well, Y is in the middle, Y is the vertex name, and then X and Z can go on either side. Okay, so I've completed the diagram for the first sentence. Now I need to add on to it with this second sentence. It says that YW is a ray in the interior of angle XYZ. Okay, angle XYZ, we already have that part. We need to draw a ray in the interior of it. And that ray has an endpoint of Y. So basically I need to start at point Y and draw a ray inside of angle XYZ. And I'll just put another point on that ray and call it W because I was told that the ray's name was YW. Okay, cool. So I drew YW in the interior of angle XYZ. But now I also need to label that angle XYW, let's see, XYW, so that's this angle, is congruent to angle WYZ. WYZ, so that's this angle. So basically the 2 angles that got created when I drew that ray, I need to label them as being congruent to each other. Well, to label angles as being congruent, we draw matching arcs. So I'll draw an arc here and an arc there. And we did it! That's all of the information that I was given, all put onto one fancy diagram. The last thing I want us to do is look at a diagram that has all kinds of labeling on it and determine whether or not we can assume that the statement we're given is true. G is the point of intersection of FH and IJ. Well, here's point G, here's line FH, and here's line IJ. Yeah, we can definitely assume that's true. That was actually the very first thing I told you in this lesson that you're allowed to assume is true, is that two lines intersect at a point. All right, that was easy. Can I assume that G is the midpoint of IJ? Okay, well here's G, and here's IJ. Well, I don't have any markings on either of those two segments that would lead me to believe that G is the midpoint. It kind of looks like it's halfway in between I and J, but unlike segment FH, where I have these fancy little marks, on IJ, I don't have any extra information about those segments. So no, I can't assume that G is the midpoint of segment IJ based on what I was told in the diagram. But what about this? Can I assume that IG plus GJ equals IJ? Well, let's see what that means. IG is this little segment, and GJ is this little segment, and then IJ is the whole thing. Well, yeah, I can assume that because of the segment addition postulate. Since I, G, and J are collinear, I can assume that G is between I and J, and that means I can assume that IG plus GJ equals IJ. Can I assume that angle FGJ and angle JGH are a linear pair? Can I assume that these two angles are a linear pair? Yep, I definitely can. Since points F, G, and H are collinear, that's a line. You can also think about it as ray GF and ray GH are opposite rays. And then ray GJ comes off of that. That makes two adjacent angles whose non-common sides are opposite rays. So yeah, by definition, I can assume that those two form a linear pair. Can I assume that angle FGI and IGK are complementary? No. Could we eventually prove that it was true? Because your brain might be saying, well, wait a second, this is a right angle, and this was a straight line, so this is a right angle, so these have to add up to 90. And if your brain is already thinking like that, that's so fantastic. But based on what we see in the diagram right now, since this little right angle measurement symbol isn't written on angle FGK, I can't actually assume yet that these are complementary. That's where proofs come in. That's where we're going with all of this, is to be able to put different elements of a diagram together and say, since this thing was this, and this other thing was that, then I could assume, by combining all of that information, that this other thing I'm trying to prove is true. But based on what I see on the diagram right now, I cannot actually assume that angle FGI and angle IGK are complementary. We would be able to prove it after a few steps, but that's not something that we can prove straight away. What about this? Can we assume that angle IGK plus KGH equals IGH? Well, yeah. These two are adjacent angles. They share ray GK and vertex G. That makes the two angles that I was given here adjacent. And I know, according to the angle addition postulate, that I can add adjacent angles to figure out the sum of the entire angles measure. This is an easy one. Can I assume that angle KGH is right? You betcha. Since we have this little marking on this diagram, this little square at the vertex, that allows me to assume that angle KGH is a right angle. Can I assume that angle FGI and angle JGH are vertical angles? Yeah, we definitely can. Because they are non-adjacent angles formed by the intersection of two lines, that means that they must be vertical angles. Can I assume that angle FGI and angle IGK are congruent to each other? Well, yeah, they're labeled, they have matching arcs, and that's enough information to show that they're congruent. And we kind of already talked about this one earlier, but can we assume that FG and GH are congruent? Yep, they're labeled, and that means they must be congruent to each other. Alright, that's all you need to know about sketching and interpreting diagrams. This was a super important lesson. You might even put a sticky note on this page or something because of how important this lesson was. You might even reference back to this lesson as we proceed through the rest of the school year. Up next, we're going to be writing our very first geometric proofs using the knowledge that we've learned today and all of the knowledge that we've learned so far this year.